In our previous video, we learned about end-to-end encryption and public key cryptography, but that raises an important question. If public key cryptography is so secure, why don't messaging apps, online banking, and websites use it to encrypt everything? Why do modern systems basically rely on two different types of encryption instead of one? Why not just improve one instead of using both? So by the end of this video, you'll understand all types of encryption, how they work, where they're used, and why almost every secure application combines both of these technologies together. Welcome. Here we break down complex tech topics into simple, practical explanations that anyone can understand. So if you're into AI, cybersecurity, or internet tech, consider subscribing because the goal is to hit 1 million by the end of this year. All right, let's dive in. So the types of encryption. Modern encryption has only two fundamental types, symmetric encryption and asymmetric encryption, also known as public key cryptography. They aren't competing technologies. Each were basically designed to solve their own different problems. Well, we're going to see each of them in depth with their examples. So starting with the symmetric encryption, it uses one shared key. That means same key encrypts the data and decrypts it. So think of it like a locker. Both you and your friend have both you and your friend have an identical keys. One person locks the locker and the other unlocks it using the same key. Because only one key is involved, the encryption process is simple and pretty straightforward and extremely fast. That's why symmetric encryption is used whenever there's large amounts of data that need to be protected, including messages, photos, videos, files, or cloud storage and data that is being sent after a secure website connection has been established. Well, the problem is that both people must already have the same key. If someone steals that key while it is being shared, they can sort of decrypt every message protected by it. So this is known as the key exchange problem, which is inside symmetric encryption. And we also sort of discussed this in the last video. Well, some of the common encryption types are your AES and Cha-Cha, and these are each the tech used for these protocols. So then you have your asymmetric encryption. To solve the key exchange problem, cryptographers developed asymmetric encryption. So instead of one shared key, every user will have two different keys. A public key, which anyone can own, a private key, which only the owner should ever possess. If someone wants to send you the encrypted data, they use your public key, they encrypt it, and only the private key can decrypt it. Because the private key never needs to be shared, the key exchange problem is solved. So the downside is the speed, because it involves much more complex mathematics, and it makes it significantly slower than symmetric encryption. Hence, not practical for encrypting large amounts of data. So instead, it's mainly used to establish trust, exchange keys securely, and support the technologies like digital signature. Now, there are some common asymmetric encryption technology types, and some of the most widely used are RSA, ECC, Diffie Hellman, and a combo of ECC and Diffie Hellman is ECDH, and then ED 225519, X25519. So you don't necessarily need to memorize all these names. Just remember that they all belong to asymmetric encryption family and are designed to securely exchange the keys, verify the identity, and establish that trust. So why modern systems use both? If symmetric encryption is fast and asymmetric encryption solves the key sharing problem, combining them together will give us something called hybrid encryption, which is fast as well as reliable. And here how it works. So first, asymmetric encryption securely establishes a shared secret between two devices, so device A and device B. And then once both devices have the shared key, they immediately switch to a symmetric encryption. So the key is shared, and then they switch to symmetric encryption, and then the rest of the connection is based on the symmetric, and the data is shared during that secure connection, and the speed of the symmetric encryption stays the same. So just to recap all of this together, modern encryption has two fundamental types. Symmetric encryption uses one shared secret key and designed for speed. Asymmetric encryption uses a public key and a private key to solve the problem of securely sharing those keys, which is caused by symmetric encryption. Modern applications combine both of these technologies using hybrid encryption, allowing them to stay both secure and efficient. That's it. If this video was helpful to you, give it a thumbs up. It really helps the channel and basically encourages us to make more videos like this. Thank you for watching, and we'll see you in the next one.